5.6, the last lesson in chapter 5. So putting it all together basically. First, when we talk about zeros of a function or finding the solutions, if we just have a parabola, this is what it would look like. Either we would have two real, one real if it just touches it once, or no real solutions. That's where our imaginary I comes in. So it's the same thing as when we have a higher degree polynomial, like a trinomial, which is 3, or quintic, which is 5. So that's what we're doing today, is figure out what the solutions are when there is a higher degree polynomial. So if this is my problem right here, what you would first want to do is go into your graphing calculator, and you want to put this into your y equals right in this spot right here. This is where you would type in your y equals, plug in your equation, and then you would graph it. Once you graph it, then you want to find one of the zeros because you're going to be dividing the polynomial by your zero. So in this case, a 0, you have to go to second. You have to push your second and trace to calculate, and you're looking for the 0 of the function. You should write this down if you have no idea what to do, but we will be practicing this in class. Once you find the 0, remember it says, we'll give you the instructions right down here on your calculator. It says left bound, so if I'm looking for this point in the middle, left means on the left side of that, you push enter. And then it says right bound, so you have to make sure to move your bug, as I call it, on the right side of this point, because you're looking for this point, the 0 of the function. And then guess, anywhere that gets close to it. Once you push enter, it will give you the 0. Now, using this 0, you have to use the actual number when you're going to synthetically divide. So we have a 0 at -2. But let's say, what if you tried to find the 0 at this point? You're never going to want to find the 0 that's in between. You want to try to find the 0 that's at a tick mark. So in this case, it says left bound. This is where people can get confused. Left bound, again, it has to be on the left side. Something's down below. You move the bug up top on the right side of it. The guess. 2 zeros here at -2 and 3. Either 0, but when you're doing this, you have to first use a graphing calculator to find the 0 of the function. Then you want to synthetically divide, and either divide again or else factor and then solve. So let's get back to that problem we just. So now we know the 2 zeros are at -2 and 3. I'm going to synthetically divide. I'm going to use my -2. So when the calculator shows the 0 at -2, that's the number that goes in the box. So I use my leading coefficients, the numbers right in front of your variables. So this becomes a 2, a -3, -11, and 6. And now I'm synthetically divide. Remember, the first number just comes down. So it's going to be just 2, and then I multiply by the number in the box. So this becomes -4. This becomes -7. Then multiply, so +14. So this would give me a +3, and multiply would give me a -6, 0. So if I write this out then, this would be a 2x squared, because my first number was cubed. So this becomes x squared minus 7x plus 3 equals 0. So again, we already know that one of my zeros is at -2. So I'm going to, whoopsies. So I'm going to write one of those answers down below. X is equal to -2. Now I have to figure out my other two answers. So now I'm going to factor this. You can either use the guess and check method, or else you can use the trick method. Two numbers have to be 2 and 1 because those are the only factors of 2. Now the only factors of 3 would be 1 and 3, or -1 and -3. So let's say if I try 3 here first and 1 here first, I'm going to make them both positive. Check your outsides. This will give me a 2x. Check your insides, plus 3x. That does not equal 7x. So I'm going to flip-flop those two numbers. So I'm going to erase that. I'm going to make this a 3. Oops, I just said that. A 1 and a 3. So guess and check. This becomes a positive 6x. This becomes a positive 1x. And that would give me 7x. However, my number should be negative. So I'm going to just rewrite this out. 2x, I have to switch the signs. And x minus 3. Now I'm going to set both of those equal to 0 because I want to figure out my other two zeros down below here. So 2x minus 1 is equal to 0, and x minus 3 is equal to 0. So my two other zeros here, I have to add 1 here. So this would be 2x is equal to 1 divided by 2 would be at 3 and 1/2. And that would be my answer. So again, like I said before, it's putting it all together at this point. So this one's a little bit harder, and they are going to get a little bit harder. So again, first you go on your graphing calculator. In this case, because I have a fourth degree, I'm going to find two zeros. I'm going to divide twice. So if I did this on my graphing calculator, I will tell you that one of the zeros would be at -3. So I'm going to put that in a box. And I also will tell you that another zero would be at 1. So I'm going to put that in a box right down here, because I'm going to synthetically divide twice here. So again, I'm going to have my 2, I'm going to have a positive 11, I'm going to have another positive 11, -15, and 9. So when I divide here, I'm going to pause the video. You should pause the video and try to do this yourself. This is what we get if you divided correctly. So then again, since I started with the fourth, this becomes the third, so it would be 2x cubed plus 5x squared minus 4x minus 3, remainder 0. So I'm going to divide again, and I'm going to write out my numbers: 2, 5, -4, -3. But this time I'm going to be using my 0 at 1. So again, pause the video and you divide yourself. And then this is what you should have came up with. So this becomes 2x squared plus 7x plus 3 is equal to 0. And actually, we just had this exact same thing to factor, except now it's a positive. So if I factor this, this becomes a 2x plus 1 and an x plus 3. Remember, we already used two of our zeros. Two of our zeros were at 1 and at -3, so I'm looking for my other two. Since these are completely factored, I set both of these equal to 0. 2x plus 1 equals 0, x plus 3 equals 0. So my other two zeros here. This is also at x equals -3. Now you can write that out again if you want to. You do not have to do that though. And this right here would give me -1 first, so I have 2x is equal to -1. Divide by 2 would give you a -1/2. So again, putting together the fact of polynomials and dividing and finding the solutions of a polynomial. Those would be my answers. And finally, the real difficult ones. However, it's not any different from the other ones. Since I have x to the fifth, I should have 5 different zeros. Now let's say if I graph this, and it looks like this right here. I would want to find the zeros. Here's a 0, and here's a 0. If you find your zeros, you would get that x is equal to -1 and 2. Now, since I have to have 5 different zeros, I'm guessing there's a multiplicity here. Remember, when it touches the 0, then turns around, there's probably 2 of them. So I'm going to use one of these two zeros when I divide by 2 times. So if I look back at my problem, whoopsies, I am going to have my -1 in the box first. And again, looking at your leading numbers, 1, -1, -5, 1, 8, and 4. So right now I want you to pause the video. I want you to divide that first. And this is what you should have got when you divided. Then I'm going to use my 2. Remember, the 2 had 2 zeros there, a multiplicity of 2, so I'm going to divide that. Again, pause the video and divide to see if you get the same answer as I do. And this is what you should have gotten when you divided, but I'm going to use that 2 twice. I'm going to, again, synthetically divide. But you have to be careful here, because remember, I started with the fourth. This is like x to the third, because when you rewrite this out again, you have to make sure to have the corresponding variables. So again, I want you to pause the video and synthetically divide again to see if you get the same answer as I do. And this is what it would be if I factor it. Now, if I factor this again, this would be x plus 1 and x plus 1, because two numbers that multiply to get your c add together to get your b. If I solve this for 0, both these are going to be the same number at x is equal to -1. Now, I only have 2 zeros here, but you do have to know what your multiplicity is here. My multiplicity for -1, have a -1 in both of these, plus I divided by -1 right away. So there's 3 zeros there at -1, and there's 2 zeros at 2, because again, I divided by -2 twice, right here and right here. So you do have to know the multiplicity. And that is putting it all together for Chapter 5, Fundamental Algebra. Have a great, grand, wonderful day.